start. Today I'm going to present the topic of research topic of image text matching. So today's the plan, talk about the description, later word, the possible solution as a image captioning, and the real solution in my desired called cross-modal architecture, details and performance, and yeah, it will go on. So basically, what's image text matching? When this topic has been getting in the investigated last years a lot, and it compromises and develop the topics of the such as big research topics, research image, image captioning, visual problem answering, and also cross-modal retrieval. So what's the problem? Let me try to explain a simple word. So we have basically simple, let's say, image data and sentence data. So we call here text or caption in next slide. So we try to represent them in some vector space, and so they can be compared with simple metrics such as cosine, similarity, or any other distance possibility. So the hard part of our project is that the two modality are really different. For example, here we have image and text, so they cannot be compared directly without designing a special function that is different for both of them. So for solving this problem, at the beginning, I tried to solve and investigate in first weeks the image captioning. So why image captioning can solve this? What's the problem? Image captioning is basically the kind of generative model, but it doesn't use the generative neural network. So we have an image, so it uses some kind of RNNs to produce a caption that describes the image in best way. So as a first, my investigation lead to the popular architecture called the Google's Show and Tell project. So this is the LSTM architecture that is creating the really sought results on the popular datasets. So the next from the Karpathy, Fei, and Johnson. This is the project of deep new visual semantic alignments for generating image descriptions. So why I cannot use this architecture in my own project? The first reason, as I said, I want to use the architecture that is different for both modalities. Like I want to use the different architecture for the image and different architecture. So I want kind of multi-model that is just getting touch in the end of the training, let's say. So here, as you see, we can pass over some RCNN, and we have some here bidirectional, I guess, bidirectional LSTM. So after processing this, they are getting merged in the middle with some layers of the neural network, and we have some function. But the good thing about this project that it's try to capture the match the words with a visual alignment, such as you see, it finds with a good what does it mean, ROI? So region of interest. Yeah, so it tries to match with that region of interest with image text tokens in a best way. So in my project now, it will use not this approach. It will use the cross-modal retrieval. Even before passing to my new approach, I coded some image captioning model, let's say, that creates a caption for some good, let's say, image captions for some images. So you can see below GitHub, but this is not my approach for image text matching. I use the cross-modal retrieval approach. As I said, I want to design, as you see here, I have C, which is this one is the images. So this one stands for the text. So I want to design two different functions, as you see, so that can be compared in a same embedding space without transforming to anything. So they are kind of projected to the same, let's say, trajectory. So we want to have such a function that is trainable. So as you see here, we have a epsilon with alpha and epsilon to the beta. So we can see we want to design function f and g that is trained, and this will be compared in the end with a single loss function without merging any architecture. So before starting my approach, I need to talk about a little bit about this cross-modal retrieval, let's say, topic. So this is the one of the best, not best, but let's say good approaches for this kind of problem. So we want to query some model of data with other data. For example, we use here bimodal data. So we want to query the text with images or query the image with text. So it takes one of the query and retrieves the relevant data another time. So okay, so before starting implementing my project, I need to do my literature review based on this. So as a first attempt, Chris et al. Made a good approach for this. So it's naive, but still it makes some good comparisons. But later the CCA approach made some solution that is as I want, which is try to design a vector space that is project both this image and sentence, let's say text data, so they can be compared in this, let's say, space. And later visual semantic embedding try to design this shared embedding in different approach. And here we have a VSC++ that is tries and get into account in loss function hard negatives, basically try to find the negative that is most influence this part and try to eliminate that most let's say hard negative. So later Microsoft in 2017 introduced CAN model that is basically uses ROS like a region of interest with the image tokens with RCNNs, and it make really good solution on different good models. And finally, Alibaba's current using fashion bird model that is still used in their website. So basically, it's for the design, especially for let's say the clothes rather than normal bird. So it uses the bird model that is not used in our model. So our model inspired by not my model inspired by the VSC++ and also canonical correlation analysis. So let me introduce also really fast my datasets. So there are three popular datasets that's available for our project, my project. So here I used the Flickr 8K, which contains the 8K 8,000 images. So as you see, we have such a words in our vocabulary, and we have also a size that is 1 gigabyte. So I divided 90% and 10% of train and test images. So, and I should also say that in dataset there are exactly 5 captions. We call caption as a text here for each of the image. I will also talk in the end of my project why I didn't use this to a dataset because of technical difficulties. So we will forward with the Flickr 8K for now. Okay, so before starting our project, still we haven't started, but yeah, we need to processing our images. So basically, we need to get features from the images that is represented in some space. Later, we will design a function, as I said in the previous slide, such that they can be compared in a same space. For that, there was a ResNet or VGG solutions. First solution was VGG network with a prepared dataset, but this dataset is really cool with a cap, and it can be used with Caffe. But the thing here, if you want to add new image to your dataset or new text lay, I mean, I cannot use the ready, let's say, pre-trained features. So I should pass over that architecture so I can get the feature for new image data. So I used the second approach, which is the ready weights ready here. So I used pre-trained 22 layer VGG16. So you can see the architecture here. Basically, it pass over this. Just we will remove the last softmax 1000 dimension layer and just get the 4096 sized feature vector. Okay, finally we come to our architecture. So I want to get some architecture that is simple as possible. That is not offered in research, as I mentioned before. They all of them mostly try to get in some complex solutions. So I wanted to have a solution that is simple as possible. For my image encoder, it is a different model, and we have a caption encoder. So it will be merged, as I said, and get compared just single time in the end. So we will see architecture picture in next slide. So we have, as I said, GG16 to get 4096 embedding vector. Later we just pass over some linear transformation and get the 1024 dimension image, let's say function dimension. So we have also a caption encoder that is passing over some transformation that is basically vocabulary size, as I showed for Flickr 8K, and we have a three-dimensional vector space. Later we'll pass over some GRU, and it will again create dimension that same as image encoder, so we can just compare them without any padding, let's say. So it can be good fun. So I drew my architecture in a my architecture. So basically we have some image coming over and passing a VGG16, which is preprocessing. So we can just throw here some barrier. So it's first phase. Laterward, we feed the data. So as you see, it's really simple that we have here fully connected. Okay, so we have a fully connected also for the text part, and it passes over GRU. And as you see, it get in touch with the two different models in a single place, which we call intermodal triple plus. I will also show inside of this formula in next slide. So yeah, we have one hot encoding for the text part, and as I said, we have 5 captions for each image. So we train together. So we have 40,000 captions when we train 8,000 images. Okay, so if you pass over the implementation details, as I said, here my written loss function, which is triplet loss. So as you see, we have a margin here. So because margin needed for this, because we are taking here max, so we don't want to get penalized in case of the negatives are bad. So here you see, this is the positive anchor, positive anchor. So here we have a negative anchor. So basically, we want to say that all images or captions that is not matching are really bad for me, and we consider them as a negative, and it's just the caption image that is same, let's say, family considered as a positive anchor, and they sum up. But here, as I said, we put the maximized with a 0, and here we have just basic, let's say, MSE type of the loss function. So we have hyperparameters, for example, used optimizer Adam, and we have a performance finally. So we have a 8T epochs trained in our architecture on Flickr 8K. So we have a see anomalies here. This is occurred because of what? Because we I saved the model here at the 2nth epoch and just stop it. And next day I just tried to continue training. So for one epoch, it's just getting to find the correct dimension one more time and just continue the same, let's say, functionality of epochs in that. So what's the rank here? This is the important part for our project, for my project. So rather than loss, the rank is important because we have as I remember in a dataset part, we had a 800, sorry, the image for the test site. So here we see 40 nearly. So that means that this is really good and works under the, let's say, 5% of the best 5%. So when you search some caption, it finds the correct matching image in a 5%. So this is unbelievable results in my side, at least I can say. So let's really fast talk about the use technology. So we use Python, PHP for user interface. I will show in the text part now, test part. And frameworks use Keras for feature extraction. As I said in first part, we are doing preprocessing for images, and also PyTorch for entire model skeleton. So we have I have the project link here in a GitHub. So also I implemented my project in a collab, so you can also leave there. Okay, so finally we pass over the test time. So we have some screenshots from my project. Okay, so user interface looks like this. When you click the caption search, you kind of search engine style. You write your, let's say, caption and just click. In a 5 or 10 second, my model pass over that ready pre-trained, which is trained by me for 80 epochs and Flickr 8K. So we have maybe limited images. So some queries can be really bad, but some queries are really good. As you see, 2 dogs laying on the grass. which give amazing result. And here is sorted by the ranking. So this first ranking, it considers a laying, let's say, verb as a important part of this image. So, and as you see, third also same, and also sixth one or eighth one also doing really good job. And one more test, which is dog jumps or the bar. I just type it in my words, and as you see, there are really good images, despite the image is limited by just 7,200 images. So if you search something different, it can be have an anomaly. So we should improve in our, I should improve in my future improvements. So I should definitely train on my Flickr 30K, despite this will take really long time. And MS Coco, which is also, as I said, 20 gigabytes of data. So I should consider, but it will take really a lot of time, despite the architecture is really simple. So yeah, train for more epochs, and the complex model can be implemented with some research. But yeah, as I said, my goal is to implement the model that is really simple, so everyone can understand the insight and improve and apply on different domains. Expand the vocabulary. This is really important. That is can be word to vec, can be used, and also this caption correction algorithms is really helpful for getting the correct caption. So for example, some letters misspelling here. Apple is with one P, so we should correct this and get the correct one hot embedding. So we can search the good, and also resonant family can be tried for the future extraction of the